What if everything we thought we knew about the universe was wrong? Imagine waking up one day to find out that the Big Bang, the colossal explosion that supposedly birthed time, space, and matter, never happened at all. No singular moment. When it all began. No rapid expansion from a single point. Just something else. For over a century, the Big Bang has been the cornerstone of modern cosmology, the narrative that explains how everything came to be. But what if that story is missing a vital chapter, or worse, entirely off track? Recent findings have begun to raise unsettling questions. Alternative theories are gaining traction, and some scientists are starting to wonder, what if the universe had no beginning? Or what if the origin was something far stranger than an explosion? In this video, we'll explore how a universe without a Big Bang could even exist, the surprising evidence that challenges the standard model. What strange alternatives like the steady state and conformal cyclic universe really propose, and what all of this means for our place in the cosmos. For decades, the Big Bang has been more than just a scientific theory. It's been the grand origin story of everything. From the glow of the cosmic microwave background to the redshift of distant galaxies, the evidence seemed overwhelming. Scientists painted a vivid picture. About 13.8 billion years ago, the universe burst forth from an unimaginably dense and hot state, expanding rapidly in all directions. This idea has shaped textbooks, documentaries, and even our understanding of time itself. But lately, a few cracks have started to show in that cosmic canvas. Observations from deep space telescopes have uncovered galaxies that appear far too mature for their estimated age, formed too soon, too quickly. Strange inconsistencies in the cosmic background radiation have left physicists scratching their heads. And in some regions of the sky, we see massive cosmic structures that shouldn't have had time to form under standard Big Bang timelines. These anomalies, once considered minor curiosities, are now forcing astronomers to take a second look. Could we be missing something fundamental? Some researchers suggest that these discoveries could be pointing toward a very different story. One, where the universe didn't begin in a fiery explosion, but perhaps existed eternally, cycling through phases of rebirth. The idea sounds radical, almost mythic, but the evidence pushing us in this direction is growing. What was once background noise is now becoming the headline. And as we peel back the layers of cosmic history, we may be standing at the edge of a revolution in how we understand everything, from time and space to our very existence. To understand how the entire foundation of our cosmic origin story is being questioned, we have to break down the science that built it in the first place. The Big Bang theory rests on three main pillars: the expanding universe, the abundance of light elements like hydrogen and helium, and the faint glow of the cosmic microwave background, the afterglow of creation itself. These clues all seemed to point back to a single moment when everything began. But science, like the universe, evolves. And now, new data is starting to challenge those pillars. Take redshift, for example. When we look at distant galaxies, their light appears stretched, shifted, toward the red end of the spectrum. This has long been interpreted as proof that the universe is expanding, like dots moving apart on the surface of an inflating balloon. But what if that redshift isn't just from expansion? Some physicists propose alternate explanations, like light losing energy over cosmic distances, a concept known as tired light. It's controversial, but it opens the door to other possibilities. Then there's the cosmic microwave background, or CMB, the faint glow left over from the Big Bang. It was hailed as the smoking gun of the theory. But when scientists looked closer, they found odd temperature fluctuations and irregularities that the standard model can't fully explain. Why are some spots hotter or colder than expected? And why are there certain alignments in the data that seem too neat? Advanced instruments like the Hubble Space Telescope, the Planck satellite, and even gravitational wave observatories like LIGO are gathering data that push the boundaries of what we thought was settled. For instance, we're seeing galaxies that formed just 300 million years after the supposed Big Bang. Too early, too structured, too evolved. That's like finding an adult human in the nursery ward of a hospital. These discoveries don't outright disprove the Big Bang, but they do raise critical questions. Could our interpretation of the data be wrong? Could the universe have followed a different set of rules? Each new observation is like a cosmic whisper, hinting that the universe may be far older, stranger, and more complex than we ever imagined. If the Big Bang never happened, then when did it all begin? Or did it begin at all? The deeper we look into time, the more distorted the timeline becomes. In cosmic terms, we're not watching events as they unfold. We're seeing light that's traveled for billions of years just to reach us. So even if something monumental happened recently in a galaxy 10 billion light-years away, it occurred 10 billion years ago in real time. This delay challenges our perception of now. It means that the evidence we're piecing together, whether it supports the Big Bang or tears it apart, is ancient, possibly from an era so remote it predates anything we've ever imagined. But what's even more astonishing is that some of the most critical data may already be here, sitting in telescope archives, just waiting for the right mind to interpret it differently. The universe doesn't send invitations to paradigm shifts. Sometimes it simply leaves breadcrumbs. Strange lights, warped time signatures, anomalies in gravitational waves. It's possible the event that disproves the Big Bang has already happened, and we're only just realizing it. If a new theory replaces the Big Bang, the shock waves won't be cosmic explosions lighting up the sky, but intellectual ones. However, the implications will feel just as breathtaking. Our understanding of creation, time, and even destiny could change overnight. A single breakthrough, perhaps buried in the light of an ancient galaxy, could illuminate the skies of science like a supernova, visible not with our eyes, but with our minds. Imagine stepping outside one quiet evening, only to look up and see a light in the sky so bright it outshines every star, and it wasn't there the night before. No telescope, no equipment, just your eyes. A brilliant point glowing like a second moon, visible even during daylight. It lingers in the sky for days, maybe weeks, casting eerie shadows at night and igniting conversations across every continent. That's the kind of spectacle humanity would expect from a nearby stellar explosion, a supernova. But in the case of the universe's origin story unraveling, the explosion is not in the sky. It's in our understanding of reality. While we won't see a literal burst of light signaling the fall of the Big Bang theory, the emotional impact could be just as luminous. It would be a once-in-a-civilization revelation, something we tell future generations about, the moment when everything changed. Scientists comparing notes, news outlets scrambling to explain, classrooms rewriting textbooks. An intellectual supernova unfolding in real time. Still, the skies might reflect this drama in more subtle ways. Perhaps we detect gravitational echoes from events we thought impossible, or a pattern in ancient starlight that tells a different story. Imagine learning that what we once believed was the dawn of time was just a chapter in a far older, ongoing cosmic cycle. In that moment, the universe becomes even more mysterious, more eternal, and we, standing under the vastness of it all, would feel both smaller and more connected than ever before. What makes all of this more than just a theoretical shakeup is how it deepens our connection to the universe. If the Big Bang never happened, and the cosmos has always existed in cycles of birth and rebirth, then everything we are, every atom in our body, has a far older story to tell. In the traditional view, heavy elements like gold, platinum, and uranium are forged in the death throes of massive stars, scattered across space by explosive supernovae. But in a cyclic universe, this cosmic recycling happens again and again, across endless ages. Stars form, live, die, and seed the galaxy with the raw ingredients for planets, oceans, and life. We've seen this process in motion through stars like Betelgeuse, Antares, and the enormous VY Canis Majoris, red supergiants that will, one day, explode and scatter their elements into the cosmos. It's in these explosions that the universe writes its future chapters. Without them, there would be no iron in our blood, no calcium in our bones, no carbon in our cells. The scientific goldmine here isn't just about disproving a theory. It's about opening new pathways to understand the fabric of reality itself. A universe without a beginning might also be a universe without an end, an eternal engine of transformation. And that makes our existence not just the result of a one-time event, but part of a grand, ongoing cosmic rhythm. We are not just observers of the universe. We are participants in its infinite story. Despite the dramatic changes in our understanding, Earth remains perfectly safe. Even if a massive cosmic event were unfolding nearby, the chances of it harming our planet are incredibly slim. At most, we might witness some beautiful effects in our own skies, like brighter-than-usual auroras or subtle changes in Earth's upper atmosphere caused by increased ionization. These are harmless, natural phenomena that only add to the wonder of the universe. What's more, scientists have developed incredible early warning systems to detect these cosmic happenings long before the light reaches us. Neutrino detectors, buried deep underground, can sense the nearly invisible particles emitted by dying stars, giving astronomers precious hours or even days to prepare. This global network acts like a cosmic alarm system, ensuring we're never caught off guard. So, while the universe may be full of surprises, we're watching closely and ready for whatever it reveals next. We are witnessing more than just a cosmic event. We are witnessing the final breath of a giant, a farewell millions of years in the making. Across unimaginable distances and eons of time, the universe unfolds its story, reminding us how small yet extraordinary our place truly is. Every star that fades, every light that flickers carries with it a legacy written in the language of time and space. As we look up at the night sky, we are reminded that the cosmos is alive with mysteries waiting to be uncovered. The story of the universe is far from finished. In fact, it's just beginning to reveal its deeper, more astonishing chapters. Each twinkle, each burst of light invites us to keep exploring, to keep questioning, and to keep dreaming. So let us hold on to that sense of wonder, the same wonder that has driven humanity to reach for the stars since the dawn of time. Because out there, beyond our world, lies a universe full of hidden wonders, waiting patiently for us to discover them. And who knows what astonishing truths the next glance upward might reveal. If you found this story fascinating, don't forget to like, subscribe, and share your thoughts in the comments below. Your curiosity helps us explore the universe